and dividing complex numbers with Mr. Hubble. First three examples we're going to do, multiplying each complex number, or in other words, finding the product. So with A, 7i times 3i. These are two pure imaginary numbers. So you're going to multiply 7 times 3 and get 21. You're going to multiply I times I to get I squared. But you have to remember that I squared is equal to negative 1. So you have 21 times negative 1, which becomes negative 21. Again, remember, I squared equals negative 1. For B, you have to distribute. So you do 2 times 4, which is 8. You do 2 times 5i, which is 10i. Next, you have to do negative 3i times 4, which is negative 12i, and then negative 3i times 5, which is negative 15i squared. After you multiply, you just combine like terms. You have 8 and no other term right now that is real. So you cannot combine anything else right now. But you can combine 10i and negative 12i to get 8 minus 2i minus 15i squared. But again, you know by now that I squared is negative 1. So you replace I squared with negative 1 to get 8 minus 2i plus 15. 8 plus 15, you get 23 minus 2i. And this is your final answer. Next up, C. Negative 4 times negative 4 is positive 16. Negative 4 times negative 5i is positive 20i. You get 5i times 4i, which is negative 20i, and you get 5i times positive 5i gives you negative 25i squared. Combine like terms, you get 16 plus 20i minus 25 cancels out, and you're left with negative 25i squared. But you know that I squared is negative 1, which reduces to plus 25, which reduces even further to 16 plus 25 is 41. And that is your final answer. So you can have a case where when you multiply two imaginary numbers, you get a real number. Last but not least, you have a rule in mathematics which says you can't have a complex number in the denominator. And in order to get rid of that complex number in the denominator, you have to multiply the numerator and denominator by the complex conjugate. When you do this, your denominator will have only real numbers. Complex conjugate means to switch the sign of your imaginary number only. You have examples 3 minus 4i, then the complex conjugate is 3 plus 4i. Negative 4i, then the complex conjugate is 4i. Negative 5 plus 8i, complex conjugate is negative 5 minus 8i. Here are two examples. Remember, you can't have an imaginary in the denominator. So to get rid of the imaginary, we have to multiply by the complex conjugate. Complex conjugate would be negative 3i. What we multiply by the denominator, we also have to multiply by the numerator. So we have 3i times negative 3i will give us negative 9i squared. Next, you also have to multiply the numerator by negative 3i. So negative 3 times 9 is negative 27i. Negative 3 times 12 will give us negative 36i squared. Now we have to reduce. We have negative 27 minus 36 times negative 1, because remember, I squared is negative 1, all over negative 9, negative 1. Simplify even further, you get negative 27i plus 36, because a negative times a negative is a positive, negative times a negative is a positive again. And then you have to break it up into two numbers. So you have negative 27i over 9 plus 36 over 9. Reduce even further, you get negative 3i plus 4, but cannot be in bi plus a form. Rewrite it as 4 minus 3i. And let me make my correction. It's 4 minus 3i. Let's try this again one more time. Can't have a negative in the denominator, so we have to multiply by the complex conjugate, which is 1 plus 4i. 1 plus 4i. Again, this is the complex conjugate. Multiplying, so we have to distribute. 1 times 1 is 1. 1 times negative 4 is negative 4i. And repeat the process, so we're going to have positive 4i and minus 16i squared in the denominator. In the numerator, we have to multiply. 1 times 2 is 2. 1 times 3i is 3i. And we have to do 4i times 2 is positive 8i plus 12i squared. Now we have to reduce. Remember that I squared equals negative 1. So we have 2 plus 11i plus 12 negative 1 all over 1 minus 16i squared. You have to remember that 4i cancels out. Reduce by substituting negative 1 in for the I squared. You get 2 plus 11i plus 12 times negative 1 all over 1 minus 16 negative 1. Simplify even further. You get 2 plus 11i minus 12 all over 1 plus 16, which reduces to negative 10 plus 11i all over 17. And remember, you want it in a plus bi form, so negative 10 over 17 plus 11i over 17 is your final answer. If you have any more questions about simplifying with the quotient, multiplying, adding, or subtracting, please see me after school.